Hey, welcome back. I'm Bud Churchward, WB7FHC. And this video is one that's a little overdue. We created it early February, but I've been traveling and not able to get it edited and ready to post. This is another video in a series we've been doing on our Saturday workshops, in which Steve Magnuson, AG7GN, is going to walk us through some of the updates that he's added to his Kenwood radio control scripts that we use on the Nexus boards. You've probably seen some of his work before, but he's added some cool things so that the controller will work with more of the applications that we have there. But before we start, here's some information you might want to know. If you'd like your own Nexus DR-X kit, go to WB7FHC.com to find all the details.
Just after 9 o'clock, so why don't we get started here? This is the second in a series of, I guess I've started calling them tech talks, for lack of a better term. I think Andy kicked them off a couple of Saturdays ago. And one of the reasons that I like to do these is that I can provide you information with, provide you a broader audience with information about updates that have been made to the Nexus DR-X. And for that reason, that we are recording these sessions, and they will be made public, FYI. They'll be available on YouTube, open to anybody on the internet. So just, for your information, that's what we're doing. Bud is generously going in after the fact, after the meeting, and he edits them down to a reasonable length. And hopefully they become useful for other folks, and then I don't have to field so many questions via email or on the groups.io list for support. So it's a win-win for everybody, I think. So we've got two topics today that we want to talk about. One is the improvements that I've made to the Python and shell scripts that I've written to control the Kenwood TM-V71A and the TM-D710G. And the second topic is enhancements that Bud has made to make his smart herd script to work with Bullseye, plus some other improvements that he's made. And we are in the process of putting that on GitHub. It actually is already on GitHub. So we're looking for some folks who are interested in testing that, and I will provide some documentation to those folks on how to get it the latest installed on their Raspberry Pi. Okay. So I guess I'll start with the Kenwood scripts that I've written. And so I'm going to share my screen here. What I have at home is I VNC into my Raspberry Pi. I'm running this Zoom session from my Mac computer. And on that Mac computer, I VNC into my Raspberry Pi. So I'll share that screen now. The 710 scripts, I call them, the script names are 710.py and 710.shell, 710.sh. And I named them that probably 2 years ago when I started writing these scripts just for myself, because I own a 710 radio. And I wasn't really thinking about the TM-V71A until somebody pointed out to me that they're identical. The cat commands are identical on both. But the name stuck. That's why it's called 710. I have the latest installed on my Raspberry Pi here, and I have it in the form of an icon here on my taskbar. So I can just click it. I see that my radio is on. And so for those of you who are not familiar with this application, it is intended to mimic to some degree the display of a TM-D710G radio. So the left side, the right side This tells you that the data side of the radio is on the right and so on. This particular update, there have been no changes to the GUI. It looks identical to what you've seen in the past. I will show you some things though on the command line that have changed. So when I click this icon down here, this actually launches a desktop file which causes this to open. You can do the same thing by typing 710.py in a terminal. And since I already have an instance open, I won't run it again, but I will run the help screen for the 710py to show you some things that you can set when you actually run the application. So if you type 710.py space -h for help, it gives you several options here. The one I want to point out is this -p, or alternatively, you can use the minus port right here. What follows after the -p is a list of devices that the Python program found that are possible serial ports that could be connected to a radio. Okay. And so the trick in getting this to work with your radio is to figure out which one of these ports is the one that's actually connected to your radio. Now, if you only have one USB, and since the Raspberry Pi doesn't have a physical serial port, a 9-pin serial port like they used back in the day, almost all of us are using USB to serial adapters, and they will show up like this. They'll be /dev/tty capital USB 0, 1, 2, 3, 4, depending on how many you have plugged in. By default, if you just run 710.py, it will attempt to connect on dev tty USB 0, and it will use a port number, a speed of 57,600. Okay, so if your serial port is not dev tty USB 0, you have to figure out what it is. And in the README for this particular application on GitHub, I give you instructions on how to figure out which port you're using. And I also provide instructions on how to create your own alias for that port so that you can call it dev/Kenwood if you want to, for example. And so whenever that port is plugged into your radio, you always know that it's going to be called /dev/Kenwood. Okay, that's in the README.
Question?
Yep. Mm-hmm. Go ahead.
What speed does the radio default to?
That's a good question. I don't know. It's been so long since I set this up initially. I don't know what it defaults to.
Where is it settable in the menu of the 71 and the 710?
Yeah, that's in the README as well. You go into the menu and you set it up.
Apologies.
Yep.
Thank you.
Mm-hmm. So by default, it'll use /dev/tty USB 0. It'll attempt to use that port, and it will use a speed of 57,600. Okay. The other options that are in here that are new are this option right here, the -X. And this is explained in more detail down here. Okay. It's the TCP port on which to listen for XML RPC rig control calls from clients such as FLDigi or HamLib. So FLDigi, some of you may be familiar with FLRig, which is a program to control various ham radio rigs. And you can set up FLDigi to use FLRig to control your radio. The support for the TMD710G in FLRig is somewhat lacking in that it's not really the fault of the FLRig developer per se. It's just the way the radio behaves. And I covered this in a previous meeting. If you look here, you can see that you can move the push to talk and the controls from either the left side or the right side of the radio. I should call it the A or the B side of the radio. And if you use the commands without a lot of care, and you like to use your radio such that you have the left side for voice and the right side for data, like I do, and you use the regular cat commands to switch between the two, or to set a frequency on the right side, by default, all of the push-to-talk controls will move to the side of the radio that you want to set the frequency on. Okay, so that's kind of the drawback of using it in FLRig, for example, and in HabLib directly. So what I've done with this release is I have configured this Python script so it appears to FLDigi like an instance of FLRig. It looks like it's talking to FLRig, but in fact, it's actually talking to this application right here. And I did the same thing with HamLib. So if you run HamLib rig control daemon, it's called, and you run it in FLRig mode, it will communicate with this application instead of FLRig. And I put controls in this application such that when you issue commands to change frequency, for example, in FLDigi, it will only affect the data side of the radio on your Kenwood. Okay, so you won't accidentally set the wrong side of the radio frequency and think you're on the right frequency, and you end up transmitting on some random frequency that you didn't intend to do that with. Okay, so in a nutshell, I know it's kind of a long-winded explanation, but in a nutshell, the new 710 application looks like FLRig to applications like FLDigi and HamLib. Okay. The other thing I have implemented in this application is I have implemented remote control push to talk. Okay, and so I have this -R option here. You can also use --rig. You can select none, which is the default, or left or right radio for the Nexus DR-X. And if you select left radio, it will know to use the GPIO pin 12 for push to talk, and the right radio, it will use GPIO pin 23. So that tells you the way I've implemented this script is that it will actually activate push to talk using GPIO. It will not send the push to talk command to the cat command to the radio. The radio supports push to talk via cat, but I do not implement that because of this weird behavior. Whatever side you send push to talk command to via cat, that side has to have PTT enabled on it. And so, like I said, this will have to be over here in order for that to work. And it just creates a big mess that I've covered earlier. So push to talk is implemented here, but it happens via GPIO. Okay, so it's designed specifically for the Nexus DR-X. Dave asked a question earlier. How does he get this window to launch in the small version? This is the regular size version and the small version. So what you do, Dave, is you add, when you edit your desktop file, or when you launch it from the command line, you provide the -S option. That brings up the small version of it. Okay, so as an example, I'll close this and I'll put -S, and brings up the small version. Okay. All right, I'm going to not run the small version because it's a little hard to see. So I'll bring up the bigger version here. The other options that have not changed from the previous version is you can specify the location at which to open the window using the -L or -- location, and the X and Y position in pixels on your screen where you want the window placed if you want to do that. Okay, any questions on the command line? Okay. All right, so let me do a demonstration here. Like I said, this hasn't changed, so I just clicked on the frequency here and I brought up a box and I can change the frequency to 145.58, and that sends a command to the radio and changes the frequency on my radio to 145.58. This little window here tells you the what I call jobs that the script has queued. And so it queued a job to change the frequency on the B side to 145.580, and it tells you when that job was finished. Okay, so that's what this little window here. There'll also be messages that might pop up in different colors for warnings. For example, if you set certain parameters here that require that the radio memory location be changed, a warning will pop up here saying you're modifying the memory location. Okay, so let me start FLDigi, and I have that in an icon down here as well. So this particular is Bud's smart herd script there is running, and we'll cover that shortly. This is the instance of FLDigi, in my case, on the right side of the radio, which I've labeled Kenwood here. And in order to set up your FLDigi to work with this new Kenwood script, you go into configure, and this is all on the README, but I'll show you it here anyway. And you go to rig control FL rig. You check this box. You put localhost, and you put host or port number 12345. This port number is configurable on the command line when you launch the script if you want to change it. The default is 12345, which is the default for FL rig. That's the reason I chose that script. The other reason is at HamLib, you can only use 12345. You can't specify a different port. Okay. So you check this box, enable FL rig receiver control with FLDigi as a client. This will have no effect. It says shut down FL rig with FLDigi. Well, it's not going to actually close this program when you check this box. So you might as well leave it unchecked. Local host, because it's communicating on the same host as a Raspberry Pi, port number 12345. There's another option here, FL rig push-to-talk keys modem. Now for most Nexus DR-X users, it's not necessary to check this box because we've already implemented push-to-talk under GPIO here. So we've enabled GPIO here, and we've selected, because I'm using the right radio, it's BCM pin 23, and the value is on, okay? So this takes care of push-to-talk for us, so we don't need to use FL rig push-to-talk keys modem here. If you want to, you can go in here and disable this, go back to FL rig and check this box, and it will still work. Because what will happen here is that FLDigi will send a push-to-talk command to this script, which will in turn activate the GPIO pin on either the left or the right radio, depending on which side you told this script to run on. Okay, but generally you just leave this unchecked. All right, so close that. Now, you'll notice that the FLDigi has synced up with my script here, and I can change the frequency here. So go like that if I want to, and then that'll change here, and it'll also update FLDigi. So it works just like FLRig does. Or I can go to FLDigi and put 145.020, for example. Whoops. Be sure to put it in. FLDigi wants to see frequencies in kilohertz, not in megahertz. Okay, so I put it in here and it updated here, and my radio is now also now at 145.020. The other option you can change here is the modulation. I don't recommend changing from FM to narrow FM. Normally we would just use FM all the time, but this works as well. Because the 710 does have an AM band for aircraft band, you can also select AM. However, that won't work. You can select AM, but there will be no effect on the radio or on the script here. Okay. So that's basically how it works with FLDigi. You can change the frequency in FLDigi. You can change the frequency. There, I just clicked on the 6 there, and you can see it changed it here. You can change the frequency on the script here if you want to in FLDigi, or if I go to my radio and I change the frequency here, then that'll be reflected on both the script here and in FLDigi. Okay. All right. So I'm going to close this app then, and I'll give you a demonstration of what happens when you run Direwolf with it. So to run Direwolf, what I normally do is I go to the ham radio menu and I run the Direwolf TNC and PAT GUI, which brings up a window. And in that window, I go to rig control. Gives you some information about ham live rig control. And I select manage rig control. And I see that the rig control daemon is running for FLRig. That appears twice here just because how ham live prints the text for the different rigs. But you can put in anything you want in here, and it'll search for all the rigs that HamLib supports. But in our case, since we want it to work specifically with FLRig, is I just put FLRig in here, and you can see that that's ID number 4, and you check that box, and then it'll start running rig control D, expecting to communicate with an instance of FLRig, which, like I said, is actually our Python script here. Okay, so when you first run this, there's a thing called dummy here. Okay, so when you first, let me close this here. If this is the first time you've run this script, the first time you've run rig control and you do manage rig control like this, it's going to look like this. Rig control is running for HamLib dummy. Okay, so in order to change it to work with your Kenwood script, or yeah, the Python script, you type FLRig, find, check this box, save changes and restart. And now it's communicating with FLRig. You want to make sure that your Kenwood 710 script is running before you do this. Otherwise, this will kick up an error message that says, I can't find an instance of FLRig. Okay. So I'm going to leave that as is. I'm going to go back here to the monitor window, and I'm going to open a PAT web interface for my PAT WinLink email. And under action here, and I've covered this in a past session, I go to connect. I have already put in some aliases for local VHF AX25 stations that I communicate with regularly. So when I select BTEC here, you can see what happened is that the frequency changed to BTEC 144990, 144990 down here. That was in my, my alias. And my radio has changed as well. Okay, I'm going to bring this up here so we can see it a little bit better. And I have to go back because okay, it's already selected 144, and now I can click connect. And the radio, or I should say PAT, also tries to QSY again to 144990, but since it's already there, it doesn't have anything to do. So, and then it just connects here. So finally, I have rig control with the Kenwood radio that changes frequency, and the push to talk is still implemented in Direwolf via GPIO. Okay, that's always been the case, but this is the first time that you could actually use the 710 script to change frequency automatically whenever you select an alias from this list here. So if I select K7SFV, for example, it changed to 144930, or this one here, WA7GJZ 145630. Okay, so this is quite handy, and like in FLDigi, it only controls the side of the radio that data is on. So if in your rig your data side of the radio is on A, it will only ever control the A side of the radio, which is what you want with these applications, right? Direwolf and FLDigi only need to interact with the data side of the radio. Okay. Any questions on that so far? Okay. All right. This is available now via the Nexus Updater. And the Nexus Updater right here. And it's just called 710. So you check this box and you click OK, and it'll go grab the latest version and install it for you. It will not install the desktop script, which is right here. That you'll have to do on your own. And the README covers how to create that. How to create that file so you can have it in your ham radio menu. Reason I don't do that automatically is, again, I don't know the name of your serial port in advance. It might be different. It's going to be different for most people. It's likely to be TTY USB 0, as I mentioned before, but it's not guaranteed. So that's why I don't create this file in advance. Now, one other thing I should mention, when you run the updater, if you double click on the description of any of these, it's going to take you to some documentation. Okay, in this case, I clicked on the description for the 710, and it takes you to this README file that I've been talking about that tells you about the application, how to set it up. I mentioned this, how to add what's called a UDEV rule, so you always get the same name. That's in here. and how to distinguish between cables with the same make and model. I had a situation where I have two USB to serial cables from the same manufacturer. And so they had the same USB identifiers in there. The vendor ID and the product ID were the same. But fortunately, this particular manufacturer chose to implement a serial number also. So I can use that as an attribute to distinguish between two cables from the same manufacturer. And that's described in here as well. I cover the command line options, and how to make a ham radio menu item is in here. And hopefully it'll be everything you need to set it up. This is how to set up FLDigi, which I covered before, including a screenshot on how to set that up, how to use it with HamLib, and how to operate the 710.shell script, which I'll go through now. Okay. So let me close this. And okay. Oh, cancel that. And I will close Direwolf just to get it out of the way here. I think at least one of you is using the 710 shell script instead, in addition to the Python script. This GUI here is a Python script, but there's also a 710.shell.sh script, which allows you to, from the command line, set certain parameters on the radio. And the way this works is it actually communicates with the 710.py, the Python file, to make the changes to the radio. So you can do things like 710.shell get ID. Oops, get, I don't even remember the name of my own program. Get well, I'll just do something that I know works. Get info. Okay. Now you'll notice that previously this script can't already be running when you were running, if you were wanting to run this command. And that's because the 710.shell script is going to open this script in the background and communicate via the serial port to the radio in order to get the information that you requested. But an instance of this script is already running, and it's using the serial port, and only one program at a time can use the serial port. So now, if you run 710 get info, it's actually communicating with the already running 710 script, and it's sending the commands, and you can see they're being queued and executed here in the window and getting the information. Now it's noticeably slower to do it this way because there's a lot more going on in order to get the information. But you can have this running and still run your 710.shell script and get the information you want. And the same is true for changing it. You can change frequency if you want to. You can put it in memory mode. Everything you could do previously, you can do now while the Python script is running. The other thing that's kind of cool about this is that you can have FLDigi running, communicating with this script, and you can run the 710.shell script at the same time. So if you want to use 710.shell to change frequency while this is running and while FLDigi is running using this, that will also work. Okay? Did that cover your question, Galen?
Well, you've obviated a whole bunch of my code because you expanded capabilities so that I don't have to. I can use your script now with Pat. So that eliminated one whole set of code that I wrote.
Right.
But I'll certainly want to play with this and see, because it's nice being able to just, think up scenarios and be able to do this stuff using my own thought process
Sure.
and learning.
Yeah. Yeah.
So,
So I hope I haven't made it seem like setting this up and using it is a daunting process, because it's really not. Once you read the documentation, which isn't terribly long, it's a lot shorter than my usual set of documentation. It should be pretty straightforward. You can figure it out, I think, in a most straightforward way. So,
Thank you, Steve. We'll go ahead and wind this first video up there. We'll take a look at the second part in the next video, where we'll be seeing a script that I wrote in addition to FLDigi, a little add-on that I hope that some of you will try and enjoy. So, see you next time.
And hey, don't forget to subscribe, like, and share.